Welcome to Prof. Hanselka's online lessons. With me here is a question from coordinate geometry in additional mathematics. The question reads as follows. In the diagram below, D is an angle equals to 90 degrees and line AD parallel to line CB. The points C and D lie on the x-axis and A lies on the y-axis. The equations of lines CB and AC are y equals to 3x minus 9 and x plus y equals to 3 respectively. So this is the figure that we have here. Please observe it carefully. Observe it carefully. This is the figure that we have here. So that we see that the lines AC and AB, they actually intersect at 90 degrees. You're able to see there, right? That's 90 degrees. Okay. Then the question reads as follows. Find number 1, number A, the equation of line AB. Number 2, find the coordinates of the points D and B. Let's see how we go about this particular question. So this is how we go about it. So first we need to find the equation of line AB. The equation of line AB. Now we know to say the line AB is perpendicular. Take note, is perpendicular to line AC. Line AB is perpendicular to line AC. What does it mean? It simply means line AC and line AB, they meet at 90 degrees, which you're able to see here, right? I guess you're able to see. That's the 90 degrees here. They're able to meet at 90 degrees, as we're able to actually see here, right? Line AC and line AB, they meet at 90 degrees here. That's what it means. Okay? So what we do here is this. For us to know the equation of line AB, given the equation of line AC here. So what we're going to do, we're going to write the equation of line AC first. The equation of line AC is given as x plus y is equals to 3. So we're going to write this particular equation in the form of the, the standard equation of a straight line form, which is y is equals to mx plus c. Okay, so we're going to write this particular equation, the line AC, in this particular form. Okay, so if you do that, we are going to have this. So the equation now is like this. So from here it's just a matter of comparing the gradient. We see that the gradient of this particular line AC is -1. So the gradient is basically the coefficient of x here. So in this case, the gradient, which I can say this is m1, or the gradient of line AC. Take note, this line is actually line AAC. This is the line here whose gradient is actually -1. Take note. Okay, so I'll label it M1 as the gradient of AC, the line AC. Now remember, we want to find the equation of line AB. Okay? So we know to say the equation of line AB will be obtained from the same equation of the straight line standard form, which is y equals to mx plus c. So now here we see that we need to establish and find the gradient of this line AB. How? We're going to use the concept of the gradients of perpendicular lines equals to the product of the gradients of the perpendicular lines equals to -1. So if you have m1 times m2 the gradient of these two perpendicular lines will equals to -1. The product of the gradients of the perpendicular lines will equals to -1. Now here we already have m1, which is -1 here. So we want to find m2, which is the gradient of line AB, correct? So where we have m1, we put -1. So say -1 times m2 will give us -1. And we divide over 1 over -1 here, also here over -1. We cancel that. We have m2, which is the gradient of AB, will equals to 1 into 1 is +1. So the gradient of AB is actually 1. So the equation now becomes y equals to, where we have the m, we put the 1. 1 times x is simply x plus c. Now it's the matter of us finding the value of the c, which is the y-intercept. So how do we get to find the y-intercept? It's very simple. So what we're going to do here is to actually figure out how best we can find the y-intercept. Now, how do we find the y-intercept? So we go back to the graph. Here we see that on our diagram, we see that we have, two lines that meet at line A. Remember, the y-intercept C, it has to be a y value right at point A here. So what is the y value at point A? We don't know. So what we're going to do is to use the concept of the parallel lines. We see that line CB is parallel to line DA. Remember, parallel lines have got equal gradients. So in the case of line CB, we see that its gradient is 3, and the same will be true of line DA. So line DA, its gradient will also be equals to 3. So what we'll do here is this. We're going to actually appreciate that we come up with the line AC, line DA. So line DA, we can say line DA can be obtained by saying y is equals to mx plus c, where we know its gradient will equal to line CB, which we know it is +3. Are you seeing that? And that's what you do. So in this case, we say this will be y is equals to, where I've got the m here, we simply plug in the 3, and this will be 3x plus c. Once again, it's the matter of asking ourselves to say, okay, in this case, what are we going to do? Well, so what we're going to do in this particular question is to simply say, okay, we are comparing this particular equation, which is the equation of line DA. The equation of line DA is this equation here, which you are seeing, and this equation this equation meets AC at A. You see? Now we know line AC is x plus y is equals to 3. So what we're going to do here is this. We're going to say where we have the y, we're going to replace and put the 3x plus c. So say x plus 3, x plus c equals to 3. Then we're going to have 4x here plus c is equals to 3. Remember, you ask yourself a question here to say, we want to find what c, remember, is, which is the y-intercept at A. So in this case, the c, remember, the point A is actually along the y-axis. Okay, so this simply means that nx value on the y-axis equals to 0. So A, in a sense, its coordinate will actually be 0, y. So in this case, we know to say the 0 is the x value and the y is the y as it is. So in this case, we're going to plug into this particular formula and see where we've got x, we're going to put a 0. So we're going to say 4, you open the parenthesis, you put 0 plus c, this will equals to 3. The idea is to find what y, which is the y-intercept, in this case represented by c, actually is. 4 times 0 is nothing plus c is c equals to 3. So in a sense, the y-intercept c is actually the 3. Therefore, we get back to our equation. Remember, the equation now finally becomes, so say the equation of line AB now becomes y is equals to x plus 3. and this becomes the solution. Thank you for watching. Please try to go through this particular question so that you see how we go about it. Remember, the first thing is to appreciate the fact that the lines AB and AC are perpendicular, meaning the product of their gradients equals to -1. So if you know the gradient of one line, then it's easy to find the gradient of the other, in the sense that we're going to negate the reciprocal of the given gradient, and that will be the gradient of the other line, because the two lines are perpendicular to each other. Yes, they meet at 90 degrees, just like we saw in this particular question. This is simply how you go about answering question number A. Find the equation of line AB, easily calculated. Thank you for watching. Please follow me along as I answer question number B, where we'll look at how to find the coordinates of the points D and B. Let's now look at the B part, which requires us to find the coordinates of the points D and B. Please observe carefully. So let's concentrate on point D. So point D, we see that that point is being shared by two lines. Yes, by two straight lines. I've got a line DA and the x-axis. Take note. Line DA and the x-axis. So first of all, write the two lines that are sharing the point D. Okay? So we have line DA and the x-axis. The x-axis, yes, the x-axis is also referred to as y is equals to 0 line. Okay? These are the two lines that share point D. So then we know to say the line DA has the equation y is equals to 3x plus 3. And we have another x-axis whose equation is y is equals to 0. So now I want to figure out the coordinate of point D. So what you do, we just have to actually appreciate the fact that the two lines, they meet at point D. So where I've got the y, we're going to put a 0. So where I've got the y here, we'll put a 0, and this will equals to 3x plus 3. Then we say 3x is equals to -3. X is equals to -1. Therefore, take note, the coordinates of point D will equal to -1, 0, because on the x-axis, any y value equals to 0. Therefore, the coordinates of point D are -1, 0, and this becomes the first point. Now let's move on to point B. Equally, we observe carefully and check what point B is. In this case, we see that point B is that point there. Point B is being shared by two lines, AB and B. How do we solve this one? Follow along, please, as we solve this particular question. We do exactly the same as we did in the previous question. So we now look at the coordinates of point B. We see that point B is being shared with two lines, CB and AB. Now we need to know both two lines. So we're going to say line AB. We previously found that line AB is actually y is equals to x plus 3. Then we also have another line there, line CB, which is line CB is given as y, if you can see, is given as y equals to 3x minus 9. So we're going to do the same thing that we did to point D. So we're just going to find out what x and y values actually are. So we see that y equals to x plus 3, and here y is equal to 3x minus 9. So it's logical to actually just equate these two expressions, x plus 3 equals to 3x minus 9. So we're going to say 3x minus 9 must be equals to x plus 3. Then so for x, we're going to say 3x minus x equals to 9 plus 3. So 3x minus x is actually 2x, which is equals to 12. We divide by 2, we have x is equals to 6. Remember, point B is x comma y. Already we know what x is. X in this case is 6, but y not as yet. Now let's shift attention and find y. For you to find y, you simply pick one of the two equations there. So you can pick the first one. So the first one is y is equals to x plus 3. Now we know what x is. What will be y when x is equals to 6 plus 3? So y is equals to 6 plus 3, that's 9. Therefore, the coordinates of point B will be 6, 9. And this will be the solution. That's how you find the 2 points. Yes, that's how you find the coordinates of point D and B. So you see here that the coordinates of point D are negative 1, 0, and the coordinates of B are 6, 9. And these become your solutions. Please go through this video. It's quite interesting. Remember, it's quite interesting. You just have to concentrate on the shared point, find out the equations or the straight lines that are sharing that particular point, and equate them. After equating them, you find one value at a time, and do that in the next question. Thank you for watching. See you in my next video. This has been Professor Hans Luka. Thank you.